continuing our series looking into TMUA. This is from 2017 paper 1. This is question 9. Okay, let's have a look at this. A circle, it gives us an equation of a circle, and then it tells us some things. It tells us a hexagon is drawn inside the circle, so the vertices of the hexagon touch the circle. What's the area of the hexagon? Right. So we're not really concerned about where the center of this circle is, but we do need to know its radius. That will give us everything we need to know to work out the area of this hexagon. So let's try and do that first. What have we got? I'm going to complete the square twice because it's in classical form. We need it in the standard circle form. So what have we got? We've got x minus 9 squared minus 81 plus y minus 11 squared minus 121 plus 178 equals 0. These two, when you add them up, you're going to get 202. 178 is 22 plus another 2 is 24. So we're going to get x minus 9 squared plus y minus 11 squared equals the square root of 24 squared. So the radius, let's write it down, r equals root 24. So we've got the radius of our circle, and we're not concerned that the center is at 911. So let's just try and picture what's going on. We've got a hexagon inside a circle. So a hexagon, 1, 2, 3, 4, 5, 6 sides, and then if we think about it, let's just pick a triangle from this hexagon. If all the angles round the hexagon go round, if you go around a full hexagon, you're going to get 360 degrees. But if you're going to divide the hexagon up into triangles, there's going to be 6 triangles. So the angle at the center for each triangle is going to be 60 degrees because 360 divided by 6 is 60. And then the radii, clearly it's a circle, so these are all the same length. So therefore, if you've got two lengths of the same in a circle and an angle of 60 degrees, you've got 6 equilateral triangles. Let's just draw the very top one of these separately. What do we know about this? I'm going to just divide it up a bit. We know the angles are all 60. Not going to worry about that. We're already using that information. The radius here is 24. So this is 24. This is 24. The distance here, this is just going to be a half of root 24. So that's enough information now to work out the area of this whole triangle. Area of this triangle up here is a half the base, which is a half root 24, times the height. That's not going to work, is it? That's not going to work. We need this height here. So what have we got? We've got this squared minus this squared. So this is 24 minus a quarter of 24. So this is 3/4 of root 24. It's the square root of that as well. So the height here is root 3 over 2. So we're going to end up with, so this is actually going to be root 3, this is 24. So we're going to end up with the area, let's just do it all in one big go. The area of the whole thing is going to be 6, because there's 6 triangles, times half the base. Base is a half root 24, times the perpendicular height, which I'm now saying is root 3 times root 24. Root 3 times root 24. So we end up with That cancels with that, becomes a 3. We end up with the 24, the root 24s become 24, which is 12. 3 12s, 3 times 12 is 36. So that's 36, and there's a root 3 over. So 36 root 3 is the answer. And here we are, it's F. So that's the answer to this question.